Okay, next we have JJ coupling scheme. In such a coupling, I'll define it first. In such a coupling scheme, orbital and spin angular momentum of each electron are added to form the total angular momentum, to get the total angular momentum. Ji for each individual electron of each individual electron. Finally, all this angular momentum of individual electrons are added to form the total angular momentum. Total angular momentum. Like suppose we have a 2 electron system. Then suppose we have a 2 electron system. This is electron 1 and this is electron 2. Then we have to calculate the total angular momentum of this electron 1, which is equal to the sum of angular momentum of electron 1 plus spin of this electron 1. Similarly, we get the total angular momentum of electron 2, which is equal to the orbital angular momentum of electron 2 plus spin angular momentum of electron 2. Once we get the total angular momentum of each electron, then we can add these two angular momentum to get the total angular momentum of this whole system. In other words, if let's suppose we have n numbers of electrons, then we have to calculate the J1, which is equal to L1 plus S1, like the total angular momentum of electron 1, which is equal to the orbital angular momentum of electron 1 plus spin of angular momentum of electron 1. Similarly, we will calculate J2, the total angular momentum of electron 2, which is equal to the orbital angular momentum of atoms 2 plus spin angular momentum of electron 2. And similarly, finally we get the total angular momentum of nth electron, which is equal to the orbital angular momentum of nth electron plus spin angular momentum of nth electron. Once we do this, then after that we will calculate the total angular momentum J, which is equal to the total angular momentum of electron 1 plus total angular momentum of electron 2 plus total angular momentum of electron 3 and up to plus total angular momentum of electron n. So by this way we get the total angular momentum, which is equals to the sum of angular momentum of each individual electron. Now this method, like if I represent it diagrammatically, then it look like this. Suppose we have 2 electrons, then we have the orbital angular momentum of electron 1 is this one, and the spin angular momentum of electron 1 is this one, and we have orbital angular momentum of electron 2 is this one, and we have spin angular momentum of electron 2 is this one, which is S2. Then first we will calculate the total angular momentum of electron 1. So this is here, I will bring this S1 here. This is S1. So the total angular momentum of electron 1, J1 is this one. Similarly, I will calculate the total angular momentum of electron 2. So I bring this S2 here by adding this vectorially. So we have the J2. This is the total angular momentum of electron 2. Now I have to calculate the total angular momentum, which is equal to the sum of total angular momentum of electron 1 and total angular momentum of electron 2. So the total angular momentum is this one. This is J. So this type of coupling is called JJ coupling. Now this type of coupling is useful when the interaction between spin and orbital vector of each electron, I can write it here, like this method is useful, or this method is employed when the interaction between spin and orbital vector, spin and orbital vector of each electron is stronger than the interaction between either the spin vector or orbital vector of different atoms. Like if we have two different atoms, not different atoms, but it's different electrons. If we have two electrons, then these two electrons interact with each other through their spin, and also they interact with each other through their orbital angular momentum. So if the interaction between the spin and orbital vector of each electron is stronger than the interaction between the spin or orbital vector of different electron, then we can use this JJ coupling. And also this type of coupling exists mainly in heavy atoms. It exists mainly in heavy atoms. Heavy atoms means having large number of electrons in the valence shell. So this was all about JJ coupling. In the next video, we will move towards the magnetic moment due to orbital angular motion, and as well as magnetic moment due to spin motion of electrons. Until that, thank you, and hope you will understand this lecture. And if you have any problem, then we can discuss it by arranging a class through Google Meet. Thank you.